I am going to introduce Dr. Brian Greene, but of course before we get started, if everyone could take a moment to silence their phones. I think we're in for a fascinating evening. Dr. Brian Greene is an acclaimed speaker. He is a physicist, a string theorist, and author of The Elegant Universe. Brian Greene is one of the world's leading theoretical physicists and a brilliant, entertaining communicator of cutting-edge scientific concepts. The Washington Post described him as the single best explainer of abstruse concepts in the world today. In The Elegant Universe, Greene recounted how the theories of general relativity and quantum mechanics transformed our understanding of the universe and introduced us to string theory, a concept that might be key to a unified theory of the universe. The book sold more than 1 million copies and became an Emmy and Peabody Award-winning Nova Special that Greene hosted. His second book, The Fabric of the Cosmos, spent 6 months on the New York Times bestseller list and was adapted into a 4-part Nova miniseries for broadcast in 2011. His third book, Icarus at the Edge of Time, is a futuristic retelling of the Icarus myth, in which a boy travels not to the sun, but to a black hole. This visually stunning fable for children has recently been adapted for stage presentation with an orchestral score by Philip Glass and premiered at Lincoln Center's Alice Tully Hall. Greene's latest book, Hidden Reality, Parallel Universes and the Deep Laws of the Cosmos, explores the strange and exciting possibility that our universe may be one of the many populating a grand multiverse. Greene has many media appearances from Nightline and Charlie Rose to The Late Show with David Letterman, and has made cameo appearances in the films Frequency, Maze, and The Last Mimsy, as well as the television show The Big Bang Theory. A graduate of Harvard and a Rhodes Scholar at Oxford, Greene is a professor in both physics and mathematics at Columbia University. The World Science Festival, co-founded by Greene, premiered in New York City in the spring of 2008 as an annual celebration of science that brings together great minds in science, business, government, and the arts. Please join me in welcoming Dr. Brian Greene.
Thank you. So it's a pleasure to be here for a nice, intimate conversation about innovation and science and all sorts of things that circle around those universe of ideas. And I'm happy for you to interrupt at any point with any questions or thoughts. We can keep this as informal as we would like. And it's a wonderful time in physics right now, because I think, as many of you know, we are on the cusp of the 100th anniversary of the discovery of the general theory of relativity. And I know you all have been busily planning your own relativity parties and celebrations, which is good, so we can sort of get things into the right frame of mind here tonight. And the wonderful thing about the general theory of relativity is it provides a wonderful case study in how a particular group of individuals, a certain collection of minds that had the capacity to see beyond everyday experience, see beyond the things that would normally make us anticipate that the world works one way, see beyond that and realize that it works in ways that experience would never, ever lead us to believe. So what I'd like to do here tonight is tell you 3 little stories that illustrate that point, illustrate the idea that there is so much more to the world than we would think, and how it's an amazing fact that we puny little human beings walking around on this rock that's orbiting a nondescript star in the corner of an ordinary galaxy have amazingly, through the power of thought and calculation, have really been able to figure out so much about how the universe works that you would never think based upon experience. So all of these stories basically will start with the general theory of relativity and will take the ideas to places that even Albert Einstein himself resisted. Even Albert Einstein himself didn't think were right, but which modern observations and experiments have shown are actually part of how the world works. So because each story uses Einstein's ideas from relativity, and because, I realize that you all, me too, we all have busy lives. Because of that, sometimes we let our understanding of general relativity get a little bit rusty, right? So I'm going to spend a little bit of time at the outset just saying a few words about general relativity itself, and then we'll take off from there and see how the next generation and the generation after that, who came after Einstein, were able to take his ideas, rework them, rethink them, and push them into startling new places, which even today we're still trying fully to figure out. All right, so starting it off with the general theory of relativity, what is it? Well, it's a theory of how the force of gravity works. Gravity is the most dominant, pervasive force that describes and molds and shapes how the universe, how the cosmos behaves on the largest of scales. And gravity itself is a story which has a long history, right? I mean, we all learned in high school that way back in the 1600s, Isaac Newton was there in England, and to escape the plague that was sweeping across Europe, wiping out so many people, he retreated to the safety of his family's home in the countryside of England, and through the ability to take mathematics that he was a master of and use that mathematics to describe the patterns that he was seeing in the world around him. Patterns of how an object would move in flight, patterns that would describe how the moon orbits the earth. He was able to encapsulate all of those patterns in a single mathematical formula, which showed him that it's the very same force that's governing the moon and comets and planets that's governing the motion of an object, a rock that is thrown here on the earth. He unified our understanding of terrestrial motion and motion out there in the cosmos with his famous universal law of gravity. And just to get us all on the same page, what does that law say? Bring the lights down a little bit. It says that every object in the universe pulls on every other with a force that depends on two things: how big they are and how far apart they are in space. There's a little equation that encapsulates that, and using that equation, you can make predictions for where the planets should be. And when you look up in the night sky, and the lights back up, the planets are, in fact, just where the mathematics says that they should be, right? And the math was actually quite simple, right? It's the same math that we teach to high school students all around the world. Today, we still teach it, right? The equation is F equals G M1 M2 over R squared. Little tiny equation you put right on a t-shirt, and using that math, you can do these miraculous things. Predict what should happen out there in space. Now, because of the success of Newton and his equation, for 200 years, everybody let gravity just sit. Nobody really thought much about it. Nobody tried to push the ideas further. Nobody tried to innovate with the equation that Newton gave us, until somebody else came on the scene, a thinker that the world had never encountered before, a thinker for whom there was absolutely no such thing as received wisdom, right? No such thing as questions that had been settled in an earlier age and therefore were done, were tied up in a bow, couldn't be reanalyzed. And that thinker, of course, is Albert Einstein. When Einstein began to cogitate on Newton and this law of gravity, he said to himself, yeah, it's close to the truth, because clearly it's making predictions that are borne out by observations. But Einstein realized that it couldn't be the full truth. And he realized that by asking the kinds of questions that, a 5-year-old would ask, right? I used to have a 5-year-old, right? Now, she's 8, but I know these kind of questions. You know them well. It's the questions where you look out into the world and you're totally uninhibited and you really want to know how things actually work.